Hello and welcome to this video for Basic Sentential Logic and Formal Fallacies and Cognitive Biases, Chapter 4. In this video I'll be talking about material that appears in section 4.1 of the text, and the topic specifically is indirect proof. And what we're going to do is first I'm going to give a quick description of what indirect proof is and a very quick example, just so as we go into more detail, you have some idea of what it is we're talking about. Then I'm going to give two explanations for why it works, or two ways of understanding why this technique works. And then I'll do a few more examples, or another example, I think, after that. So with indirect proof, your goal is to establish or to derive some statement alpha, and this could be anything. It might be the conclusion of the argument, which would be why you're trying to establish it. It might be a statement that you realize if you had it would help you get to the conclusion, but whatever, at some point there's some statement alpha that you want to derive. But rather than establish it directly just by using the rules or using conditional proof, you establish it indirectly. What does that mean? Not by deriving alpha or showing that alpha has to be true, but by showing that not alpha has to be false. And of course, if not alpha is false, then alpha is true. Well, how do you show that not alpha has to be false? And the idea is that you show that by assuming not alpha, and then showing that you can derive something that you know is false from that. And in particular, we'll be deriving a contradiction, because contradictions are things we know are false. Okay, so that's the basic idea. That may not make a lot of sense right now, but it will after we talk about it some more and I show you some examples. By the way, it also goes by a few other names. Indirect proof sometimes is called proof by contradiction, or reductio ad absurdum. That's the Latin for reducing something to absurdity, or showing that something reduces to or leads back to an absurdity. Here's what it will look like, and it's a subproof, so it's like conditional proof. So suppose, and these are just generic statements, it doesn't matter what they are, but suppose we have two premises and a conclusion. Maybe I've derived a line already, but at some point there's some statement that I'd like to get alpha. Call it alpha. It could be atomic, it could be compound, it doesn't matter. But I don't see a way to get it just by using the rules on the lines I already have, or by using conditional proof. Okay, but now we've got a new tool, indirect proof, so I decide I'm going to try that. What's that going to look like? Well, I'm going to start a subproof. And just like with conditional proof, I'm going to start the subproof by indenting. I'm going to have an arrow and a justification. But what's my assumption going to be? When I start a subproof, I need an assumption to start it. With conditional proof, remember, you assumed the antecedent of the conditional you were trying to derive. What is your assumption going to be for indirect proof? Well, the assumption is the negation of the thing I'm trying to derive. I'm trying to derive alpha, so my assumption is going to be the negation of that. So I put not alpha here. My justification is going to be assumption for indirect proof, AIP, and I'm going to put a little arrow there, just like I do for conditional proof. So it's a subproof like conditional proof. You indent, you have an arrow, you have a justification that is an assumption for the type of subproof you're doing. Okay. My goal now is to derive an explicit contradiction. Remember, with conditional proof, once you made your assumption, there was a certain goal you had. Specifically, you were trying to derive the consequent of the conditional you wanted. Analogously, with indirect proof, once you make your assumption, there is a specific thing you're trying to derive. In this case, what you're trying to derive is an explicit contradiction. What is an explicit contradiction? It's a conjunction where one conjunct is the negation of the other conjunct. So it's a contradiction. If you did a truth table for any statement that had that form, you would see it's a contradiction. But what it has going for it is that those are contradictions where you can just look at them and see that they're contradictions. I'll talk more about that later. But that's your goal, is to derive an explicit contradiction. Which means that my proof will look like this. I've made my assumption, I'm going to keep deriving lines. Eventually, I'm going to get an explicit contradiction, so a conjunction where one statement's the negation of the other. Once I've done that, I close the subproof. The subproof is finished, so I draw my little line up to the top arrow, just like with conditional proof. And the next line after I close an indirect proof subproof has to be the negation of my assumption. Here my assumption was not A, so the next line here will be, not alpha, will be alpha. It could also be not alpha, because remember, I can negate something by either adding or subtracting one tilde. So if you subtract one, you get alpha. If you add one, you get not alpha. So either of those are legit. Now, it might also be the case that alpha is the conclusion, in which case you would be done, but it might not be. Maybe alpha was just something you needed as part of the proof, and you might continue on after that. Okay. Let's see an example, a real-life proof where I'm going to use indirect proof, and then we'll go back through more carefully and explain how it works. But this is what it would look like for a real proof. So I've got two premises. I have my conclusion. Notice, by the way, that this proof would be easy to do without any subproofs, right? If you could just look at this and see, oh, I'm trying to get not x and not y. You've already got not y, so you've got one of the two conjuncts already, and you can get not x by modus tollens. So I get modus tollens on 1 and 2 to get not x. Then I just conjoin 2 and 3, and boom, you're done. But suppose you didn't see that. If you didn't see that, you need to practice more seriously, but just for purposes of illustration, suppose you didn't see that. You might think, well, gosh, I don't know how to get that. I can try indirect proof. Okay, I want to derive this conjunction. I'm going to use indirect proof, so I'm going to assume the negation of what I want and then derive an explicit contradiction. Well, what I want is this conjunction, so my assumption is going to be the negation of that conjunction. Okay, and I'm going to do the arrow. That's going to be my justification, AIP. What I'm going to do is I'm going to derive lines until I get an explicit contradiction, then I'm going to close it, and then once it's closed, my next line will be the negation of my AIP, which is this, and I'll be done, because that's the conclusion. So here's what it would look like. Oh, and the justification would be lines 3 through whatever this last line of the subproof is, indirect proof. So this is what it would look like. I don't see that I could do it with modus tollens and conjunction, so I think I'm going to use indirect proof. Indent, that's the negation of the thing I want, because I'm going to use indirect proof to just derive the conclusion directly. So I'm going to assume the negation of the conclusion. Justification is AIP. My goal now is just to derive an explicit contradiction. I want a conjunction where one conjunct is the negation of the other conjunct. How can I do that? Well, I'm going to do De Morgan's on line 3. This is a negated conjunction, so I'm just going to turn that into a disjunction. Dot becomes wedge, negate both conjuncts, not x becomes x, not y becomes y, and remove the outside negation. Now I have a disjunction. Line 2 is the negation of this disjunct, so I can get x by ds. Line 2 and 4. I have x, so I can get y with modus ponens on 5 and 1. And now I'm looking at this, I'm thinking, oh, I've got the materials for an explicit contradiction. I have y and I have not y. So if I conjoin these, I have a statement. It's a conjunction where one conjunct is just the negation of the other conjunct. This is an explicit contradiction. Now, there's a lot of other explicit contradictions I could have derived here, actually. So if you think about this and you do this proof, try to derive different explicit contradictions. But this is just the one I ended up with. But now that I've got an explicit contradiction, I can close this subproof. I've got my line up here to show that this is closed now. And the next line has to be the negation of my AIP. Well, this was my AIP. I'm going to negate it by taking one tilde off, this tilde out here. And I just get not X and not Y, and I'm done, because that's the conclusion. Okay. And my justification is the entire subproof, lines 3 through 7, indirect proof. So this is an example of how this might work in real life, on a real life proof. Now that you've seen an example, let's go back through and explain why, what's the thought process behind this? Why does this work? Well, there's a couple of ways to get your head around it. And I'm going to give you two different ways to think about it. One way to think about it is that it's related to modus tollens. Remember modus tollens. If I have a conditional, and if I know that the consequent is false, then the antecedent must be false. Okay? So if I have not alpha then beta, and I know that not beta, I can derive the negation of the antecedent. In this case, the antecedent is not alpha, so I can derive alpha. So to put it in words, I know that if not alpha leads to beta, and I also know that beta is false, so not alpha leads to something that's false, then not alpha has to be false. Okay, and if not alpha is false, then alpha is true. So in the real world, people do this all the time. Okay, you use modus tollens, or you show that a certain assumption leads to something false, so that assumption has to be false. So suppose Ashley says, I don't know why your plants are dead. I watered them just yesterday. Marta thinks Ashley forgot to water her plants and is kind of irritated. So Marta says, if you had watered my plants yesterday, the dirt would be moist. But look, the dirt isn't moist. It's completely dry. So you didn't water the plants. Okay, perfectly normal, makes perfect sense. Okay, but let's look logically at what's going on here. Here's two atomic statements. W is Ashley watered the plants, and M is the dirt is moist, let's say. Ashley is putting forth W. Ashley's position is Ashley watered the plants, or she'd say I watered the plants, because she doesn't talk about herself in the third person. So Ashley's position is W. Marta wants to establish not W. She thinks Ashley's full of shit. She thinks that Ashley didn't water the plants. So Marta's goal is to establish not W. How is she going to establish that? Well, she's going to use modus tollens to show that W has to be false. Okay, so let's walk through the reasoning here. Marta wants to establish not W, so that's her goal, not W. The key bit is this. She shows that the opposite of what she wants, what's the opposite of what she wants? Well, she wants not W, the opposite is W. So she shows that the opposite of what she wants leads to M. Okay, or if W, then M. She then demonstrates that M is false. She did this by saying, hey, the dirt isn't moist, the dirt's dry, so M is false. So not M. By modus tollens, if you know that if W then M, and you have the negation of the consequent, you can derive the negation of the antecedent, so not W. So she's reached her goal, right? Her goal was to establish not W, and she got it. And she did it this way, by showing that the opposite leads to something that she knows is false, that you can establish has to be false. Okay. Indirect proof is similar. I'm going to sort of do a side-by-side here. You want to establish that alpha is true. Doesn't matter what statement it is. but that's your goal. You assume the opposite of what you want and show that that leads to beta. Okay, if not alpha, then beta. Think of it that way. And beta is something that we know is false. Well, if not alpha led to beta and beta is false, then not alpha has to be false. And if not alpha is false, then alpha is true. Okay, so it's very similar to modus tollens. It's a kind of application of modus tollens, actually. I want to focus on this bit, though, because in the Marta example, the M was, she just demonstrated M was false. The ground is moist. She demonstrated that's false by just, feeling the ground and saying, hey, look at this ground. It's totally dry. How do we know that beta is false in a proof? Okay, we don't want to have to go feeling dirt in the middle of a proof, right? We don't want to have to go check on the world. So even though Marta could establish that M's false by looking at the dirt, we don't want to have to do that. Okay, so what can we do? How can we derive something we know is false if we're not going to go feeling dirt? Well, remember, a contradiction's always false. So if the thing that we can derive, this thing beta, is a contradiction, that's how we'll know it's false. Because we know contradictions are always false. They can't possibly be true. So we want beta to be a contradiction. And moreover, we want it to be a statement that we can tell is a contradiction by just looking at it. So remember when we were doing truth tables to determine whether a statement was a contradiction, sometimes you couldn't tell just by looking at it. It might be a really complicated statement and you'd have to do a truth table. We don't want that. We want the beta to be something that we can just look at and see as a contradiction. And that's why we want beta to be not just any old contradiction, but an explicit contradiction. Because if you just look at a statement and you see that it's a conjunction where one of the conjuncts is the negation of the other, you know it's a contradiction. Okay? And so it's going to be any statement of this form. Delta, so it's a conjunction of some statement and the negation of that same statement. So P and not P, this is an explicit contradiction. This is also an explicit contradiction, right? We've got a statement conjoined to the negation of that same statement. That's fine too. It doesn't have to be atomic. So explicit contradictions, they're false, and we can tell they're false very easily just by looking at them. So that's why they're our goal. Here's another explanation. This is actually a slightly better explanation. Not that the other one's wrong, it's just this one's a little bit better. It's in terms of truth preservation. So think of it this way. At some point in a proof, you decide you want to be able to derive alpha, but you don't know how. So far, just the same. You add an assumption consisting of the opposite of what you want, not alpha, and you use the rules. Now we know the rules are truth preserving, which means that if you apply them to statements that are all true, you're only going to be able to produce true statements. Okay? But suppose you manage to derive a contradiction. We know contradictions are false. How on earth could you derive a contradiction using truth-preserving rules? Okay? The only explanation is that the statements we were using the rules on couldn't have all been true. Okay? Because by the definition of truth preservation, if they were all true, if all of the things we were applying the rules to, if all of those statements were all true, we could never derive a contradiction. So they couldn't have all been true. Something that we were applying the rules to had to be false. Okay? The only thing that's suspect was our assumption. Everything else was a premise or something we derived directly from a premise, and we're assuming that those are okay. Now, they may not be, but don't worry about that. The only thing that is suspect was our assumption, so that has to be the thing that was false. That's the culprit, okay, not alpha. And if not alpha is false, alpha has to be true. Okay, so that's the other way of thinking of it. Let's do another example. Here's a proof. We have 3 premises and we're trying to derive D. You could pretty easily, well, I don't know how easy it would be, but I don't think you would need to use indirect proof here. In fact, if you're looking for proofs to do this without indirect proof. But you can use indirect proof. You might look at this and say, you know what, I don't immediately see how to get D, but fine, I'm just going to use indirect proof. I'm going to assume the negation of the conclusion. I'm just going to derive the conclusion with indirect proof. I'm going to assume the negation of the conclusion, not D, and get a contradiction. Well, now that I've got not D, I can get A by modus tollens. So not D is the negation of that consequent, get the negation of the antecedent by modus tollens. I have A, so I can do modus ponens to get if B then not A, and that's by 5-2 modus ponens. I have B, so I can get B, so I can get not A. And I've already got A here, so here's the materials for an explicit contradiction. I have a statement and the negation of that statement, so I can just conjoin those into my explicit contradiction here. Now I can close the subproof. Next line has to be the negation of my AIP. Remember, there's 2 ways you can negate something, add or subtract 1 tilde. I'm going to negate this by subtracting 1. So I'm going to put D here. And the justification is the entire subproof, lines 4 through 8, indirect proof. Okay, that's it for this video. In the next video, I'm going to do some more examples, and we'll go through some rules for using indirect proof correctly.